Hello guys, what's up? So today I'm going to teach you guys about derivatives and what a derivative is. So to understand some of this stuff, you need to understand your basic maths from pre-calculus. So like you need to know how to factor, you need to know basic addition, subtraction, division, multiplication of polynomials and things like that before you begin on this lesson. But no further ado, let's begin. Now I've actually drawn a graph here. This is y is equal to x squared. You'll have seen this in many other classes. If you've taken basically any math class, you'll know this function is a parabola in its shape. Y is equal to x squared. X squared is the actual function itself, and y is the actual variable. And this is a parabola that opens upwards. Now, if I asked you a specific question, what do you think the slope of this graph is? In this case, it gets a little more difficult. So, for instance, let's go back to basics here. So we understand that slope of a line. This is a basic straight line. Let's say you have this line, and this line is it's straight. It's going up, just basically vertically, constant rate. At a constant rate, that means when your y is equal to your x at some point, and then each x is equivalent to a specific y at this rate. Now, if I would ask you what the slope of this line is, this would actually be pretty easy. You could use the formula y2. You could use the formula of y2 minus, let's say y2 minus y1, and then that's all over, basically all over x2 minus x1. So it's basically the same thing. So what this formula is asking you basically is to just choose a point on the graph, or 2 points on the graph, sorry. So let's say like right here and right here. And you know that, okay, let's say that this point is some 2 numbers, and then this point has some 2 numbers. You would just plug those values into this formula, and you'd get basically m, which is your slope. But this is a very straightforward example because it's just a straight line. Now, if we're to go to this point here, this is a curve, basically just curving upwards. But what a derivative does is basically finds an instantaneous rate of change. That basically means that at any given point on this curve, there is a slope. So for instance, at this point, your slope would be going up like this. At this point, your slope would be going down like this. So at each point, and then here, you would have no slope. This would just be 0. So it's just a flat line like this, where your x is equal to 0 and your y is equal to 0. And then here, this is basically the same thing. It goes up like this. So at each point, each single individual point has a slope here. Now, in order to find the slope of this entire curve, we need to do what's called a derivative. And that's what I'm going to show you guys. So let's write this out here. So let's say y equals, so let's actually write this out in text. So y is equal to x squared. Okay, so this is the formula. So in order to take the derivative of this function, we need to take essentially the exponent. So in this case, there's an exponent, so x squared. What the trick to do here is we take this exponent here, right here, and then we basically plop it down right in front of the x. Okay, so instead of y is equal to x squared, you'd get y is equal to 2x. Now what happens to the exponent? When you pull this exponent down, you're not moving the entire 2 down. You're actually going to subtract 1 from this exponent, and then 2 minus 1 in this case is just 1. So in this case, your derivative would be y is equal to 2x. That's it. You don't need to write the 1 because it's a 1. And then this is just, so dy is equal to 2x dx. That's basically your derivative. So basically, what's that saying is that the slope of this function is 2x. And then 2x, if you basically go back to your algebra, is basically the straight line with the stretch of 2 on the line. So it's going to be up, or it's going to be a little steeper than a regular, just y is equal to x. So instead of this line, let's say this line is equal to x, your 2x would be something like this. It would be a lot steeper because as this number here increases, your line will become steeper and steeper. And as this line becomes like a fraction, so let's say 0.5 or something like that, it would be a very strange line. You could put that in your calculator and you can see what it is. So let's go and try another derivative here. This is black this all out here. Okay, so that's good. Let's take another function. Let's say, let's give a polynomial. Let's try a polynomial. So as a polynomial, you understand what a polynomial is. A polynomial is basically multiple variables with x. So let's say y, this is a bit hard to see, y is equal to, I'll actually write this in text. So we'll say y is equal to, let's say, 2x squared plus 3x plus 12. Now in this case, there's actually no need to factor here. What you might have learned in other courses is that you need to factor this using either just basically foiling everything out or using the quadratic formula. But in this case, we're going to ask you what the derivative of this function is. Okay, so the derivative of this function is basically the derivative of each individual component. So let's take each one of these portions of this equation individually. So let's go 2x squared. So in this case, y is equal to 2x squared. Now we'll do the same thing as we did before. Pull the 2 down next to the 2. So actually it becomes 2 times 2x squared. So 2 times 2, as you know, 4x. And then when you take the exponent down, remember we subtract this exponent by 1. So it basically becomes 4x to the 1, or just 4x. So that's this component complete. Now what happens if you have a variable to 3x where the exponent is 1? Well, you pull down the 1 and then you do 3 times 1, and then 1 minus 1 is 0. So this x will actually just disappear and this will become a constant. So the derivative of 3x would just be 3. And the derivative of the constant, 12, because in this case 12 is your constant here at the very end. The derivative of this is just, there's no derivative, it's just 0. There would be nothing there. So the derivative of this function, of this particular function, is y is equal to 4x plus 3. And that's the slope of this particular curve. That's basically all for today. I'll see you guys soon, or very shortly.